Okay, hello everyone. Thanks for joining us for the GIS in Action first track here of day 3. We have 3 great presentations for you today. So, and of course this is being recorded. So hopefully you will be able to get a lot out of this. I know these guys are going to be really great. My name is Jamie Dennis, so I'll be the moderator today. And since we only have an hour, each presentation is going to be about 15 to 18 minutes each, and hopefully if there's time, we'll have time at the end of each presentation. If there's enough time, we can do questions. But if you have questions as they're presenting, please put them into the chat, and I will keep track of those, and I will ask your questions to the presenters at the end of their presentation. So without further ado, another thing is if you want, please remember to keep your microphones muted and your video off, and to make the best of it, if you go to your view menu at the top and you put hide non-video participants or Control-Shift-H on your keyboard, then you'll just see the one person, the presenter, when they're presenting, you'll only see their video on there. So without further ado, I'm going to introduce Bill Beaver. Bill, I'm going to pass you the presenter ball here.
Okay.
And while he's getting set up there, I am going to, and Bill, if you want to turn on your video, you can, but we definitely will be able to need to hear you.
As long as I'm dressed.
Okay, so I'll be able to share it.
Okay, here we go. Is everybody be able to see this?
Oh yeah, it looks great.
Okay, great.
Let me give you a little introduction first, so people know a little more about that. So Bill, for those of you that don't know Bill, he's been with Santa Cruz County for 5 years as a GIS senior analyst. He's got a master's GIS from the University of Arizona. He's been an itinerant programmer for over 40 years. He's a math instructor at Pima College in Tucson for 16 years. And if you didn't know this, he's also doing a hands-on workshop on Survey 123 tomorrow morning, which you can find in the program. And so without further ado, I'm going to turn it over to you, Bill.
Hi, how you doing? My wife is teaching a high school art class in the other room, so I hope it doesn't bleed in. This is the roadway management system. I'm Bill Beaver. And let's get started. So wait a minute, I have to move this little thing out of the way. There we go. Santa Cruz County now has 2 versions of our roadway system. The road center lines, which community development uses, emergency management uses, the 911 system uses it, ADOT uses it, and other state agencies, and the general population uses it. We also have a street system that Public Works uses. Wait a minute. There we go. Okay. Each one of these roadway systems is segmented differently, meaning the road itself is broken up into pieces. The road center lines have intersections, have a left-right ESN boundary, have a left-right MSAG boundary. It has bump outs, which are sort of wide spots in the road where they've put a bunch of parcels that kind of join at one spot. It's sort of like a court, but it doesn't have a road to it. It's just like half of the circle. And some of these have different addressing in the bump out. It also has a road class, which is freeway, state, local, or Forest Service. The streets also have intersections. Everything has intersections. It also has owned by, whether it's owned by Nogales or owned by private, maintained by. Some of the owned by are maintained by others. And special county maintained ones, such as surface classification, Hearst classification, and county classification. These all have different segments. And you can see this is the ESN. And I know the idea is to have the ESN boundaries become the GIS boundaries, and everything will run off of that, and then the roadways won't have to have the ESN on there. But there's still some issues with us. There's still some issues. You can see in those arrows in the top one, it's on 52. The bottom one's in 57. And the middle arrow, you can see it's part in one and part in the other. So the parcel on the right is in ESN 57 if they ever build a house there. Now, some of them follow the roadways, some of them don't. So it's moving the ESNs. Moving the ESNs are easier, but moving municipal boundaries, which we have the same issues with, has become real hard because they have to go through the board. Each of these road systems has a different set of attributes. The road center lines have left-right address range. The name is all in caps. The name is parsed for an address locator. In streets, the names are capitalized and some of the abbreviations are not used. These are the way the streets are going to be put on the signs, so they have to be a little different. There are also paved and unpaved miles. And also some of these bump outs, more than in the road center lines, have to be marked. Okay, the history. From 2006 to 2008, a feature class was created from paper maps for the road center lines. In 2016, I added UIDs for road names and segments. In 2017, we added the Forest Service roads. With the streets, in 2008, these were cloned from the road center line and segmented by hand. And there were thousands of segments that I had to remove later on. 2016, the road name UIDs were matched and the street segment UIDs were added. In 2017 to 18, these two UIDs were added to signs, guardrails, drainage, and other public works assets. Between 2018 and 2020 in February, the field survey of the county we've been doing. That was stopped because of the virus. From 2019 to present, we've started the development of a driveway and entrance point layer. And I'll tell you about that later on. Also, remember that all these boundaries were created originally from paper maps. So this includes the county boundary, which we had a lot of trouble adjusting. Okay, the issues is road name changes, new roads, boundary changes, road surface changes, and it requires a bit of work across multiple layers. Now, the field work and the imagery has shown that there's many errors in the original road center lines. They had roads going from one place to another, and there was a canyon in between and no road. So the road ended at one side of the canyon and started at the other, but it showed on the map as it going through. The error fixes did not always go into the street layers just because of time. Plus, the error fixes were fast and crude that were done on the road center lines. They were not, the roads were not redrawn with a point set that was smoothed and turned into a line and smooth. So it was not compatible with the linear referencing system. So also we need a new road system based on the boundaries of tax and legal districts. And again, we have drawn sort of like the ESN layer where all the different emergency layers are combined into like a puzzle. We had to do this for all the legal layers for the state last year, but none of these changes in the boundaries have been approved by the council, so by the supervisors. So they're not legal. This will have a separate addressing system based on this segmentation. our public works consultant has started redrawing the roads to be more LSR compliant. I've assisted with this. These redrawn roads need to eventually be added to the system. Okay, so here's our fieldwork map. The green is commercial. The orange with the dot is landmarks that don't have addresses, sort of like parks and stuff like statues and things like that, special markers, special signs. The yellow is your addressing. The stars, the orange stars is the parcel stuff that we have questions to ask the assessors about what's going on there. Although the big dots on the lower right is an area that we haven't covered yet. So that small area of things, this stopped in, as I say, in February, early March. The things that look like pink snowflakes are addresses that aren't correct, meaning that they're going to a road that they're not on, or the parity is wrong, something like that. Now we have an existing system that takes this field work and combines it and does the data confirmation, the data creation, and then scripting. And the scripts generate the address points. When I first came in here, we didn't have address points. So they are generated from all this information. And because they're generated, the address points were put on the buildings rather than on the road. And then after this, it routes different versions of the features to different locations. Different people want different things, and they have a different schema. So the schema has to be changed. Sometimes the projection has to be changed. This is all done. Changes of the roads can be plugged into the system. So this is an existing system that I can add on to. Here is a very simple version of the system and how it works. And the updates go to the scripts. The address points are created. The non-address landmarks are created. All the different versions of the roads and the buildings and whatever are created. Some of them go to our 911 system that has a different one. Some of them go to AZGeo. Eventually, this will be in our web thing because now we can use a REST service. Okay, so that's a very simple version. Okay, a certain road system has a set of points that both define and segment the system. And some of the points, there's a start point and there's an end point. And there's also an intersection point. And also there's special non-segment points like overpasses. So we have to know where the overpasses are. Fortunately, there isn't a whole lot of overpasses in our county. Okay, so here's the intersections. And if you see one on the right, that is a road that loops around on itself. Okay, so it intersects with itself. Now, ADOT requires that we split that loop into 2 segments. So that is something that's a special case that we have to work with. Another special case is number 2. That's where a road of one name ends and a road of another name begins. And so we have this, and this is actual stuff, not an example. And you can see our houses, address houses, and also the driveways and how they go in. Okay, so when you segment an intersection, well, when it's segmented, the direction of the road from start point to end point stays with the segments. Okay, so of course the addressing would start at the start point and go to the end point, and you'd face that direction, and that would be left or right. So what you can do is you would associate with these points an address, and it would be a left and right address. And what part of the road is. Is it the start of the road where the start comes in, or where the end where the end comes in? Okay, so the end would come in and the start would leave. Okay, so but the problem is the position of the buildings don't always tell us where the buildings are on the road if we want to generate this from that. So we have another project in which we're creating entrance points. And you can see the entrance points. You can see a problem. There's 932 Via Puebla. It is on that side of the intersection. 929 starts on the other side. So the numbers left and right do not match completely. They're off, and sometimes they get off like hundreds of numbers. Okay, we also have a project to realign the roads. Here's some ones that have been done. There are actually more, but I just wanted to show you how this is done. And eventually we want to take these realigned roads, segment them for the road center lines, segment them for the streets, and also segment them for our municipal boundaries and legal boundaries. Now we're using Arc Pro with this. All of these things that we have a list of what we're going to use, and called a project. I call it a project, and we do a point feature, and then we do them all in a point feature. Then we take this point feature, we create the points, and then we run create line, and the points are turned into lines and then smooth lines. Okay. Any questions?
Wow, you finished like right on time. That's awesome. We did have one question in the chat from Bo, who wants to know what are bump outs.
Oh, bump outs. Yeah. Well, you know, when you have okay, so you have a court. You know what a court is? It's a road that's got a little circle at the end of it, right? A bump out is a half circle. Okay, and a half circle is attached to the road. It doesn't always have a separate name. So you have a main road and you have this bump out, and all it is a bunch of parcels pointed to the other one. I should have drawn a picture of this to explain it better. So it's a half circle. Sometimes it's an actual court that still has the original road name. It was never renamed. So the problem with this is people address the road, and then they took a big parcel that was in the middle and they created this bump out of it, and there are now 3 or 4 parcels in the middle of this bump out. Well, the ones on the left differ from the ones on the right by just 2 address numbers. So they actually have different address numbers. So the road will go 754, 1028, 1030, 1032, 1034, and then it will go to 736, or 734, I guess, whatever it is. So you understand what I'm saying?
Yeah, I think that made sense. Bo says thanks. We have, I guess, time for maybe one more question if somebody has a question, but I don't see any more in here. So thank you very much, Bill. And I did not see the selfie in the selfie slideshow today. That doesn't really look like you, but.
Which one was it? The grayscale one or the other one?
Grayscale one you had in today, but I was just talking about the one you have on your slide here. So. All right. Well, thank you, Bill. That was great.
Oh, this one. That one. Yeah, that's my alter ego. Groucho Marx.
Okay. All right. Okay. Thanks, Bill.
Okay, all thank you.
Great presentation. All right, so next up we have Chris, and I'm going to pass you the ball to present here, Chris. Hold on. Let's see. All right, Chris.
Yes, I am trying to get the.
Hit the share button at the bottom there. There we go.
All right. Can everyone hear me?
Yeah, let me tell everybody about you real quick,
Okay.
and then we'll get you rolling. All right, so Chris Turner has over 15 years of GIS experience and has worked in various roles ranging from GIS tech to software implementation specialist. Currently, Chris works for Maricopa County Office of Enterprise Technology as a GIS analyst. In this position, Chris assists in the management of Maricopa County Department of Transportation's linear referencing system and the implementation of mobile GIS solutions. So with that, Chris is going to present to us on leveraging ArcGIS Online. And Chris, you can even turn your video on if you wanted to. So I'm going to turn it over to you. And again, if people have questions, please put them in the chat. Go for it, Chris.
Thank you, Jamie. First off, good afternoon, everyone. Thank you for taking a few minutes out of your day to join me for my presentation. I'm sure everyone is really hard at work working on exciting GIS projects. I sure speak to a lot of y'all when I say the demand for GIS has almost doubled since the beginning of COVID-19. So once again, thank you for taking some time out of your day to listen to me. Before we dive into the presentation, I wanted to review my role as GIS analyst for Maricopa County. While serving as GIS analyst for the county for 7 years, I worked on various projects for various departments, such as Department of Transportation, Flood Control District, Parks and Rec, and most recently, Office of Emergency Management. Thanks, COVID. As much as I love helping other departments see the benefits of GIS, my main responsibility is to provide Mcdot's asset management team with GIS support. One of the projects that I've been involved in over the past 3 years is Mcdot's yearly condition assessment. This condition assessment assesses all the roadway assets. This project started in late 2016 when the management team at Maricopa County Department of Transportation started having serious discussion about the direction that Mcdot wanted to go with in managing its roadway assets. After multiple conversations and the help of a consultant, it was decided that Mcdot needed to develop a Transportation Asset Management Plan, or TAMP known at Mcdot, to better understand the current state of its assets and where it wanted to be in terms of managing all these assets. This plan would help serve as a guide to make data-driven decisions and develop a whole agency systematic approach to managing Mcdot's roadway assets. The TAMP was developed with 4 main pillars, as you can see: inventory, condition, level of service targets, and unit cost. These 4 pillars serve as a broader yearly process that includes identifying the assets, surveying the assets, identifying the current service level of those assets, setting a service level for each asset, and determining the cost to achieve the determined service level. So I'll be focusing mainly on my presentation on these 2 first pillars, inventory and condition. As you might imagine, GIS is directly related to the inventory pillar. Mcdot has a robust GIS system that includes roads and highways, and cartograph to manage its asset inventory. The second pillar that will be highlighted in this presentation is condition. The condition element of the TAMP was defined as assessing the state, which is the functional and structural quality of its assets, and determining their service level. With guidance from a consultant, the framework for a yearly condition assessment was established. This assessment, since the county is so large, would involve a sample of the overall asset inventory. It was determined that 250 intersections would be the base number for identifying the collection areas. For each intersection, assets were assessed within 1/10 of a mile from the intersection. As you can see here, here's a list of kind of the amount of assets that Mcdot inventories and keeps track of. It was also added some other assets. They're not part of GIS, but are part of cartograph as part of the assessment. These were kind of vegetation management areas and lines of sight around corners and just certain intersections. They were also added, but those are not maintained in GIS. Initially, my involvement in the assessment was to randomly select 250 intersections using our existing roads and highways data. If anyone knows anything about roads and highways data, intersections are kind of tricky to work with since they're multi-tiered intersections. So a lot of analysis had to be used to actually remove a lot of duplicate intersections and calculate and to run Python to do random selection. These intersections were related to 3 functional classes: collectors, arterials, and local roads. My initial involvement was very minimal, but with each additional assessment, I became more involved and GIS became the bedrock of this assessment. The first assessment was timely, very cumbersome, and involved many paper Excel-like forms. Upon the review of the first year, I was asked by the asset management team to help streamline the process. After a few weeks of brainstorming and testing certain feature class schemas, I was able to replace the paper survey forms with hosted feature layers and AGL, and these layers were to be used in Collector. The use of other Mcdot reference layers in Collector also removed any ambiguity out of the collection process and helped the field collection effort. Utilizing Collector alone cut the collection process down from 3 weeks to 3 days. With the feature classes hosted in Agl, I was now able to leverage the awesomeness of Agl Dashboards. The initial dashboard I created allowed the asset management team manager to QC and review the progress of each field crew while the assessment was in progress. This allowed the manager to quickly see if the teams needed to be moved in different directions and see if each team had the same understanding of deficiency among the many different assets. With the collection information residing in digital form, I was also able to compile the data quickly into usable reports and tables from Mcdot's asset management team. In its third year, which is this year, the condition assessment became more streamlined and included more dashboards and story maps to relay the results of the condition assessment to Mcdot's management team. So I'm going to take a little quick overview tour of the apps that I created. So first off, I'm going to review the Collector app. So as you'll see, there's 5 different color points. These were the actual intersections that the teams were assigned to. And if I was to click on one, you'll see that there's barely some, not barely, but some good information about the intersection and some of the information that we could use to actually trigger dashboards to do analysis to see how the teams were faring during the assessment. So you'll see here, this is status, which actually fed right into a dashboard, which I'll show next. And then we also have a condition, basically the assessment itself. And this would allow the teams to actually answer the questions of how the assets were in the field. So you can see there's numerous questions, and not every intersection had the assets. So you'll see some zeros, but you'll start to see numbers. And with the county being so diverse, not every intersection had all the assets. So every collection is a little different. So this was the Collector app. The next one that was used was a dashboard to actually show the progress of the collection effort. As you'll see on the left-hand side, there was 4 groups, and this is the percentage of the status of each of their collections. So each of them had about 70 to collect, and you'll notice that some of them weren't collect because we hit the threshold for certain assets before finishing the final collection. We also had to go back and reassess some assets because we didn't hit the threshold for the statistical threshold to actually be a sample size. So as you can see here, it quickly allowed the team manager to see where each group stood and the functional class that was actually being collected. We also added parks in the last couple of years because they wanted to be part of the assessment and set a service level for their roads and assets too. The next app that I used was actually to display the results of this year's condition assessment to Mcdot's management team. So first off, we just gave a brief overview of the process as what I did earlier. And this is kind of the process that we used to actually do the collection. So first we created the intersections, which is the actual where the teams are going to go. Then we trained the teams to understand the different deficiency classifications per the each asset. So there was, I think, 24 assets. So there's 24 different examples of what should be classified as deficiency or deficient. And this is actually the forms itself that I worked with the asset management team and some of the field crews to streamline it to make sure it was pertinent to each asset. And this was kind of the same thing what I just showed with that allowed the QC of live QC of the collection. And this was the reassessment. So this is the red dots are where we actually had to go back out and get additional information. So you can see with the number of assets collected that it was a pretty significant effort. And then another sample of the analytical ability to display dashboard information is this is kind of the top deficient assets within Mcdot's inventory. So you can see it was quickly able to relay this information in infographics. And we're also able to show kind of pictures and explanation of why things were certain deficient. As you can see here, this definitely depicts a deficient asset, which in the overall scheme of things, pictures actually are very important when you're trying to explain deficient structures. So we also relayed this to a kind of a summary per each asset. Now I'll go through them all, but you can see here that this would actually display or show that the deficiency of a culvert. You can see that it's 25% blocked by vegetation and debris. So we did a lot of those to explain how we collected and how we quantified something as deficient. Now here's the last part of the condition assessment. This was set up, this scorecard was established to actually set as a scorecard to actually rate certain assets. So depending on the deficiency, they would get A, B, C, D, and F. And this was actually a sample of the actual scorecard from this year. And now, since I'm a GIS nerd, I was able to overlay all the deficient structures, assets, and do a heat map to relay that to Mcdot's management team. So after the initial story map was presented to the management team, it was asked to actually do further analysis and show this on a maintenance district kind of analysis. So how Mcdot's kind of budgeting, they budget based upon the 4 districts that they maintain. So the manager in charge wanted to see the condition assessment broken down further by each district. As you'll see, each of them, I gave their own individual assets kind of rating system. And it's also noted that the county is very diverse. So when you look at the Northwest, which has Sun City East, and more urban areas, you're going to see a different asset scorecard versus like the South part, which is very rural. So that was kind of the overall project and all the AGL apps I used to actually relay this very analytical data to the team in a graphic way. So before I finish up and wrap up this presentation, I wanted to hit on some lessons learned during a massive field collection as the one that this one was. This was involved 5 teams of 3 people each, so yeah, 15 people for a week the first time, then it kind of dwindled down. But one of the big takeaways was, as a GIS person myself, always be ready to adapt, because you never know how the schema might need to be changed, the reference layers, any of the services that are feeding to AGL to actually relay results or different information depending upon the manager's wishes. Second main point was have defined answers for your field collections, such as domains. This serves as 2 purposes. It serves as a standardized answers across multiple groups, so you're making sure each team is reporting kind of the same information. And second, it allows for more ease of use when compiling and displaying dashboards. So when you have standardized answers, it's easier to quantify those. And another takeaway is pictures. Pictures are to speak volume when you're trying to justify assets being deficient. And of course, everyone knows, stay up on your AGL apps, because every other week, apps are evolving and new functionality can bring light and help speed up the process. So with that said, thank you for listening to me.
Awesome. That was really great, Chris. If anybody has any questions for Chris, go ahead and type them in the chat. Well, we have a few more minutes here, but I wanted to ask you, Chris, I have a question. Did you find that these apps have been accepted? I mean, are they using them a lot? That, if you put all this work into them, we hope that the managers and all that are finding really good use for them. Are they accepting of this? Because it seems like it would be something new for them to use.
Oh yeah, so these are actually, they're all being used right now, and the new upper level manager who just started was the one who actually requested the district breakdown of the assets. So yes, these are being used right now, and this is actually going to be linked. Some of these condition assessments will be linked to the actual internal road information tool, which is the Mcdot one-stop shop for all things Mcdot information.
Awesome. It's great. It's really unique. It's like the story map is kind of like a training tool or information there. I like the way you use that. That's
yes.
Cool. That's pretty cool. Pretty cool. Well, thank you very much. If nobody else, I'm looking over here at the chat. Anything? Although Shawnee wanted to say that domains are so helpful. They are.
Yes.
Using domains.
I second that.
All right. Okay. Well, thanks, Chris. I guess
Thank
we have finish right on time. All right. Okay. So let's move on to our next presenters, and I'm going to pass the ball to Chuck. Where are you, Chuck? There you are. So Chuck, if you want to turn on your video, you can, or of your presenters or co-presenters. Did you get the thing to share your presentation? Yeah. All right. Okay. Well, that's booting up. I'm going to tell everybody about you. For those that don't know you, since you've been doing a lot of stuff here on AGIC. Really great that you're sharing all this great, wonderful information with everybody. I love it.
Yeah, every time.
Anyway, for those of you that don't know Chuck Powell, Chuck's been providing graphics and mapping support on a variety of environmental, cultural, and biological projects, and he specializes in GIS using ArcGIS and AutoCAD programs. Been doing that since 1993. He's an expert on the most current versions of ArcGIS Desktop, ArcGIS Pro, ArcGIS Online, Collector, Survey 123, Story Map, and App Builder. And now I know who to go to when I have questions on some of these. He's also in AutoCAD, AutoCAD Civil 3D, and MicroStation version 8. So he's experienced with many types of data collection instruments, including GPS, Total Station, Trimble GeoUnits, Esri Collector, and Survey 123. He also has trained outside staff on the use of Esri desktop and web apps since 2007. He currently serves as GeoMentor to 2 schools introducing students to GIS. And if you guys don't remember, Chuck also won Volunteer of the Year a few years back at AGIC for his work he does with the schools. So he's been doing a lot of really great stuff. And he's got two co-presenters with him today, and I'm going to introduce them real quick. Cathy, I will probably mutilate your last name, so I'm just going to, Cathy, I'll let you say your last name when you come up, is the administrative manager for Avra Water Co-op and has been with the company since 2011. She moved to Tucson from Southern California in 2005 and had a medical background, but found her niche in the water field when she was hired by the co-op 9 years ago. Well, that's awesome, Cathy. She leads a team of 8 that work closely to ensure the health and safety of their system. And also presenting with Cathy and Chuck is Theron. Did I pronounce his name right?
Yes.
Hope so. Great. Theron is a native Tucsonian. Hey, I'm down here in Tucson too, who wound up in the water business 6 years ago. He started as a laborer at another local rural utility and came to Avra Water 2.5 years ago to grow in the industry. He has his Water Distribution 2 certification and is very involved in the startup of our new GIS system. So I'm going to turn it over to Chuck since I probably wasted some of the time, but go for it, Chuck.
Okay. Thank you, Jamie. Sorry about those long bios. If I have a longer bio, I can not have as many slides, so shorten up the presentation. Cathy and Theron have been true partners. Agl Water Co-op have been true partners on this project of migrating their system into GIS. Agl Water Co-op is a community-owned, not-for-profit water provider that covers about 12.5 square miles out west of Tucson in the community of Picture Rocks. I believe they have 2,500 customers. So this project started as getting their system into some format that can go beyond what they have. Before this project, they had 36 base maps and a Google Earth file, and this is a picture of the Google Earth file that we started with, and Westland provided these files straight from CAD. We have been part of Avra for a long time. So we provided the Google Earth files to get them going quite a few years ago, just so they can visually see where their lines are and so forth. This year, they approached us, and we wanted to get them going into GIS to fully utilize the tools that are out there for asset management, operations, and general upkeep. As everyone knows, Esri has come out with a newer format for utility network that's been around for a few years now. And this is straight from Esri, this slide. But really, utility network that differs from the old geometric network. It models every type of equipment and models in world how that system actually flows. So you can do trace upstream, downstream, provide an operational view of how all the dynamic devices and utility that are currently configured, and actually how your network is affected by real-world events such as storms, equipment failure, pretty quickly. There's 2 types of networks that Esri is designed for. Partition, those are electric and telecommunications, and hierarchical, which are water and gas networks. And we're going to be talking, obviously, about water here with tiers, tier groups, tiers, and subnetworks. Hierarchical, your gas or water can flow from one tier to another, depending on devices such as pressure reducing or booster stations to get the water or the gas to the right pressure. Within the utility network, there's a domain network, your tier groups and tier subnetworks, like we talked about, in water, your pressure networks, your subnetworks within those, and then structure network. And structure network is all the ancillary equipment that works with your network that is not part of the water flow, as they say. So these are your pumps, poles, stations, that physical reservoir, the tanks, and so forth. So those are part of the structure network, and the pipes, the valves, and all that are part of the domain network. Here's an example of a pressure system. So the blue square represents the system, the green represents the pressure zones, and then the orange are the isolation zones, where you can isolate part of the system out using valves and other devices. But and coming from a GIS background, I've learned quite a bit about water systems now, with great help from my team at Westland, and also Theron, Sal, and everyone at Avra as well. It's been a real learning experience for me. The utility network is not just about connectability, it's about traversability. How does your asset flow through your system? And that's where utility network really shines, where they have the tools to be able to model real-world incidents, leaks, routine maintenance, and so forth, and really show how the system works and predict and manage your system very, very efficiently. The first step we went through was look at Esri's attributes that they are out of the box on the utility network. We went through it as a group, sent out Excel spreadsheets so non-GIS personnel could understand the fun joys of data dictionaries or attributes and domains and so forth. And we decided on just a few customized attributes to facilitate some workflows within Avra. One, added SID to really work with their billing software, so they'll be able to go through their historic records, their work orders, and kind of track where that meter is in the system, and retirements and replacements and so forth. Also, to help facilitate that, we assigned a customer ID to the meter as well. And this is directly for customer service and billing software. On the pipes end, we added project numbers, internal job numbers that Avra could track, and also Westland has, or one of their working engineering consultants. We've done quite a bit of work for them. And also their aid in construction project numbers, and that is outside funding that Avra has received to maintain, upgrade, or replace certain pipes in certain projects. So those were pretty much what we customized the utility network for, and the rest we left out, or not left out, that we left as is. Now comes the fun part. So we have all these beautiful base maps, and you know, these are printed out 24 by 36 that Avra has, their field operators have, and kind of give a good overview of their assets. But when you try to put them in real world coordinates, and not real world locations, coordinates was not the issue. On the map, the symbols are cartographically correct. They're not overlapping, so they're easy to read. But when we lay them out, they could be, 6 feet apart instead of 6 inches. So this is an ongoing project. We're continuing to update those as we go, but that was one of the bigger issues. So the base maps had quite a few information we needed. A lot of times we needed to drill down further. So we went back to the actual as-built, how the pipes were constructed, how was the booster station constructed, a reservoir, and so forth. We pulled as much information as we can for the attributes, such as on this tank, the size of the tank, when was it done, and so forth. And we actually attached it as an attachment to that location as well. So we were able to pull that out, but as a lot of times, and my experiences, and a lot of people's experience, sometimes as-built aren't really how they were built. So, we're going to still fine-tune that, and then Theron is going to be actually maintaining the system for ATREC, and whenever he goes out or his crew goes out, they will be updating these attributes, the locations, and so forth. We utilize ArcGIS Pro to edit. That's one thing with Utility Network. It doesn't work in ArcMap. You can view the data that you won't be able to use any of the Utility Network tools. We hosted the feature services up on Portal, so Theron, myself, and other colleagues at Weston could edit certain areas, certain features as we went to make it a true team project. We were able to do this very nicely. This is one thing I really like about ArcGIS Pro, with its working with Portal or ArcGIS Online, and editing those hosted feature services. It's a great venue for that. As you can see, this is what we got before. So on the left is the Google Earth file. On the right is the utility network and how that is going. So we have the 3 pumps, all the valves, the reservoir, the tank, and including the isolation valve. We color-coded the pipes as pressure zones. So this is a booster station where we're boosting up the pressure. One of the latest steps we've done is we just started migrating their forms from paper to tablets. Theron and I worked on this a couple weeks ago, so we'll be taking their paper forms and creating Survey 123 app surveys for all that data. This is a nice way to archive the maintenance, the regular maintenance, and also look at it, look at trends, and highlight issues before they become a problem, using either the hosted feature services, color coding them when they're hit a certain threshold, or in Survey 123 portal where you can look at the data different ways, look for trends. This is the big thing that I think is the biggest benefit for small utilities. So Esri had the utility network. It was designed for enterprise, where you would need enterprise portal hardware, either virtual or physical hardware on your location, to be able to publish and use. But they're releasing single-use model. They have a few. I know Stormwater is out right now. They're releasing single-use model for water utilities in November, where you don't have to invest in enterprise and portal. You can do everything on a single user ArcGIS Pro standard license, and AGL. So there's not a big investment that you have to spend on hardware, training, and so forth. All the analysis will be done on desktop and then republished to the web, and then published out to mobile from the web, and then back to desktop to do any of the network analysis. On Enterprise, you can do your tracing and your network analysis via the web, mobile, or desktop. But with the single use, it will be desktop only for analysis, viewing, and access mobile and the web. Like I said, the benefits that we see to a single user environment would be cost of maintenance and hardware, ability to utilize the AGL and let Esri manage the cloud environment. With AGL and ArcGIS ArcGIS Pro desktop, you get all the tools that Enterprise gives you, the utility network tools. That you also, with AGL, you get collector, survey 1, 2, 3, dashboards, and so forth. And still give each team member secured access, depending on their task and job, is what they're going to see via ArcGIS Online user access management. Like I said, this is a project we're currently still working on. The next steps is a move to a single user geodatabase in November. Currently, it's hosting on our Enterprise. And this is going to be the life of the project. Update locations, valves, meters, etc. using GPS and aerial. Theron and his group will be doing that as a normal daily maintenance issues arise. Develop apps for admin customer service operations. Develop those end user tools that the whole team at Abra will be able to use and help with their workflow. Also, a long-range goal would be public-facing map for plane maintenance and outages to support their customer base, and then also connect SCADA to the map viewers. I think that's about it.
Okay, great. Yeah, that was great. Does anybody have any questions for Chuck and the team? Like a great project.
Yeah, it's been fun. And Cathy and Theron have been great. I'm hoping Theron in next year or two can talk about his first year of experience managing and maintaining a GIS system here next year.
Okay, look forward to it. So Theron, you're on the hot seat. Theron's on the hot seat to prevent next year, right?
Yes, that would be one less I have to do next year.
Okay. All right. Well, if there aren't any questions from anybody, I want to thank you all for attending this session. I'm going to put into the chat the link back to the session page, and if you could click on the answer the survey to give some quick feedback. It's really short, 2 questions, and you can fill in the box if you want to add more comments. It's really short, and it really helps us to know what kind of presentations y'all like. Next up, you can go to their sponsor breakout session from 2:30 to 3, and then from 3 to 3:30 is the trivia fun game. So, and those are all back on the website in the program there with links to get to those. And then we'll hope to see you back at 3:30 also for more GIS in action stuff. And thank all of our presenters for some wonderful presentations. And that's it. See you guys over in the trivia games.